again. So welcome to the session. So today we are going to discuss about you know k nearest neighbors. Okay. So we will start with k nearest neighbors. After that, we will also discuss about decision tree. If time permits, I will complete today. Otherwise, we can complete tomorrow. Okay. Yeah. So KNN stands for k nearest neighbors. Here, k is a scalar. Scalar means we can define its value. We can define, for example, k is equal to 1, k is equal to 2, k is equal to 3, blah blah blah. But what is this NN? K is clear. Then NN stands for nearest neighbors, as I mentioned here. What is nearest neighbors? It is an algorithm in such a way it will takes the near points and will consider that it will the data points will follow the same properties and same things. For example, here it is a very clearly stated. Let me show you the lecture of KNN. Here it is very clearly stated. What is the assumption of k nearest neighbors is similar inputs will have the similar outputs. Okay, similar inputs will have similar outputs. Got it? So that is what the primary assumption of k nearest neighbors is. So similar inputs will always have similar outputs. What exactly this mean? Let me show you. Yeah. Here, let us consider, like yesterday, we also let us consider again the two different data points. Let us say this is one data point and one more data point. This is one more data point. Okay. Yesterday, what we did in order to classify the two different classes is that was SVM. SVM is simply, we have to come up with the hyperplane concept. We have to identify the best fit hyperplane. Okay, this we discussed the W transpose X plus B minus 1, W transpose X plus B plus 1. And this is W X transpose X plus B equal to 0. Okay. So, and also we discussed this is the distance between these two. That distance should be 2 upon norm W max. The goal is to maximize this thing. Okay, that is what the goal. Correct? Till now we learned SVM. Now it is again another way of doing. Another scientist came and they defined another approach, one more approach to do this instead of doing all such. Instead of doing the SVM. So another scientist or another what we can say, another way of solving this is doing KNN algorithm. I mean, by using KNN algorithm. And how to use that KNN algorithm means KNN stands for, again, I am just revising. KNN means K nearest neighbors. Means, for example, let me take a new point. Let us consider that this is X or features. Features. This is Y, target variable. Got it? This is X, this is features. And these are two classes plotted, which were plotted according to the data set. This is according to the data set. Let us consider. This is according to the data set I just plotted. Two classes, we can easily see and identify, right, with the help of our eye. There are two classes. One is red, one is purple. Then let me consider one more point. Let me take orange. So this is a new point. I wanted to classify this new point belongs to whether class red or class purple. I wanted to define, I wanted to know this new point belongs to class red or class purple. That is what my goal, isn't it? That is what my goal. If it is logistic regression concept, logistic, then what will you do? Simply you will calculate y is equal to beta naught plus beta 1 x1 plus beta 2 x2 up to 1, that y value, and then 1 by 1 plus e power minus y, then you will get some values. If it is greater than or equal to 0.5, then you will consider as class 1, otherwise class 0. This is what logistic regression works. When it comes to SVM, yesterday we discussed about this. Hyperplane should come, and should we are going to plan, we are going to come up with a hyperplane, and the hyperplane will decide if any data point goes here out, this line, then those belongs to class 1, and if any point below this line fall under below this line, then those data points comes under class 0. Got it? This was the SVM concept. But now how do we define using KNN? There is one more approach to do this. So that is what nearest neighbors. Nearest neighbors means assumption is simple inputs will always have simple outputs. That is what the assumption according to this KNN. Similar inputs, okay, not simple, sorry. Similar inputs will have similar. Similar is nothing but nearest, right? Near, similar. Okay. So neighbors means adjacent to this. So what we'll be doing is K is a number. I already mentioned K is a scalar which defines in this slide. You can see K is equal to either 1, 2, 3, something like that. So now what we will do is let us consider K is equal to 3. K is equal to 3. Then we will calculate. So not with K. First, not let us not consider what is the K. First of all, this data point with respect to this data point and this data point, let us calculate the distance. There is a mathematical formulation is there which can help us to calculate the distances. So one is Euclidean distance, very popular one, Euclidean, which is always square root of x2 minus x1 whole square plus y2 minus y1 whole square, right? Have you ever seen this formula? Can I get a quick confirmation? Let me take new slide. Meanwhile, anybody observe this formula? Please let me know. X2 minus x1 whole square plus y2 minus y1 whole square. Okay, so this is what distance between 2 points. So let us consider the distance. The points are, let me take one more color. This is 1 point, 2 comma 4. This is one more point, you know, 5 comma 2. So what is the distance between these two? The distance between these two means 2 minus 5 whole square plus 4 minus 2 whole square. Of course, square root is also there. 2 minus 5 means 3. Minus 3 obviously will be removed if we are squaring it. Minus 3 times of minus 3 is 9, right? Plus 2 square means 4. 9 plus 4, 13. So root 13 is what the value which is the distance between these 2 points. Correct? Similarly, when we goes to here, what will be the distance between the new point with respect to this and new point with respect to this, 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 this. We will calculate all the distances. Okay, we will calculate all the distances. Got it? So let us say there are 10 points are there. 10 points. There are, array, no, not like this. Let me take in a clear way and a simple way. X and then Y. Observe clearly and please let me know if you did not get the point, get the concept. So this is data point. These are all the data points. These are all the data points. Okay, how many are there? 4, 4, 4, 3, 7. 7 plus, let me consider these are 5. These are again 5. Total 10 points are there. Okay, and our new point is purple one, which shines here. You can see this is what the new point. Okay, this is class red. This is class orange. This is class P, stands for purple. Now I have 10 points, and this is the point which I wanted to know. Okay, which class it belongs to. Then that is considered, let us consider this point is 3 comma 4. 3 comma 4 is the point P. Okay, all the points are there. 2 comma 2, 3 comma 2, 4 comma 6. Let me consider all 10 points are there. 1, 2, 3, 4, 10 points. Distance between this to this, let us say 2, 6, 4, 1, 3, 9. So these are all the distances between, these points. Then we have to sort down, ascending order, ascending. So the ascending order sorting means 1, 2, you know, uh, 1, 2. Okay. So this actually, these are all the distances. The distances we will sort down. Okay. 1, 2, 3, 4, 6, 9, blah, blah, blah. Then, okay. So then we have to consider the k value. Let us consider k is equal to 3. Then top 3. Out of these 3, okay. Out of these 3, again we have to define. Okay, again we have to define. This particular one distance means which class it is, class red. This distance 3 is nothing but class orange. This is class again red. Class red, out of 3 distances, class red are 2, class orange is 1. Then which are having higher weightage? This one. Then this point belongs to class red. Is this point clear? Is this point clear? So let me show you the thing.
Yes, Yashwant.
Yeah. So here we can see. Okay. Here we can see. There are, let us say, 3 or 2, red and blue. So this is a point, a new point, which has to define. Okay. So which block it belongs to or which class it belongs to. So first of all, distances it should calculate, then k value, then inside k value, these 3 are near k, these 3 are very near points to it. Out of these 3, again division of the class. So red points are 2, blue is 1, then it belongs to the red. Got it? So here we can see the same way, you know, KNN. So the new point finds 3 near points. So out of these 3 near points again, all 3 are red. Got it? There is no green point comes under this circle. That is why here 0 out of 3. All 3 are red. So obviously it belongs to red. For example, it is in the between these two. Okay. Between these two. Got it? Then again k value, k, let us say 5. Then top 5 distances, out of 5 distances, and again division of the classes. Okay, out of 5, we again further have to division of the classes. So the division, whichever class frequency is more, then that is what we will select. Got it? So then how do we choose this k value? It is very typical one right now, right? Isn't it? So we understand that, okay, k is very important, which plays a crucial role to find out the values. Okay, that values actually help us to draw a circle, right? So 3 means 3 we will select. Out of these 3 again, I just told you, right? So which points are more? The red points are more and orange point is none. Then we will select red point. So this class belongs to the red. Got it? So the circle is important. The circle means we need again k. Then how do we define this k again? How do we define k? There is one, I mean, there are multiple techniques are there to define the k. One good technique is always elbow method. Elbow method is simple. We will iterate with different case. We will consider k is equal to 2, 2, k is equal to, simply k is equal to 1, k is equal to 3. So 1 we did not consider, right? The first distance, it is very difficult. 2, at least 2. The top 2 it can consider. Then 2, 3, 4, 5, 6, 7. Let us say 7 case. K is equal to 2, 2, k is equal to 7. So what is the accuracy or error? Okay, error means the actual value minus predicted value, right? So calculate error when k is equal to 2, error. K is equal to 3, error. K is equal to 4, error. Simply k is equal to 7, error. Till k is equal to 7, error. Let us say k is equal to 2, the error is very high. Slowly, slowly it dropped and then like this. So here you can see elbow shape. Wherever you identify the elbow shape, I have to find out the nearest k value like this. For example, it is in between 3 and 4. It will give 4 or 3. You have to check with whichever gives you the less error. That is what you have to pick it. Okay. 3 in this case. So let me show you the same thing here in this. K is equal to 5. By default, if you not specify any k value, by default it will consider as k is equal to 5. Okay. So here you can see the elbow method. The elbow, it look like an elbow, right? So at which k value exactly you got that k you can fix it. Is that clear? And again, when it comes to the distances, okay, the distances, there are three types of distances that I will show you: KNN, sklearn. If you go to the sklearn library, KNN classifier is what we are going to use. Here by default, I just mentioned, right? K is equal to 5 and weights are uniform, algorithm auto. What is this leaf size? Metric. Metric is what very important. And these two parameters are really important and remaining parameters are all by default. But anyway, if you are interested to know what are these, for example, algorithm, auto, ball tree, KD tree, brute, by default it is automatic. What is this ball tree? Again, this is one more representation. You can see. Okay, there is one more story of ball tree again. But anyway, these are not much like discussed. So we will mainly focus into neighbors and matrix. So this will define us. What are the matrix options are there? There are three different ways to calculate the distance. One is Euclidean distance, obviously the most common one. So otherwise, the other two things are Minkowski and there is one more thing is there. Let me see here itself. Minkowski and let me search matrix in KNN for distance calculation. Calculation. Yeah, Minkowski and Manhattan. Yes, these three are popular. Euclidean, okay, Manhattan, Minkowski. Then again, Euclidean, I just explained you the formulation, right? Then how does these two works? So if you observe it all comes from Minkowski. So if you observe the Minkowski formulation in Wikipedia, it is really easy to understand. Here you can see this formula. Okay. Here the formula is, if you see, Okay. So here if you can see the formula, summation I is equal to 1 to n modulus of xi minus yi power, I mean mod power p whole power 1 by p. Okay. So this is the same formula. Let me take this formula into, I'm trying to take out this formula to the PPT, but it is not, it is not going to select the, yes, yes, now I'm able to select. Okay, let me select first, then I will explain you how these formulas really works. Okay, so let me take the formula first. Okay, so it is very like modulus of xi minus yi mod power p whole power 1 by p, and in between summation I is equal to 1 to n. This is what the formula, right? 1 to n. Yes. So this is what the formula of mini Minkowski. This is the formula of Minkowski. Okay. So let us alter this p value. Let me take p is equal to 1. Then what will be the value? Xi minus xi means there are 2 points. Let us say. Then x1 minus y1. So and x2 minus y2. That is how it works, right? Xi minus yi because summation is there, right? So x1 minus y1, let us say, plus x2 minus y2 modulus power 1 whole power 1 by 1 means 1 only. And this is the formulation. If p is equal to 1, then this is the formulation for Manhattan distance. If you insert p is equal to 2, then what will happen? Just observe. X1 minus y1. Okay, p means 2, right? Square plus x2 minus y2 whole square power 1 by 2, right? 1 by 2 is nothing but square root. This is what Euclidean distance. Euclidean distance. Is that clear? Euclidean distance means where you're going to insert p is equal to 2. Manhattan means where you're going to insert p is equal to 1. That is why here, if you observe the scikit-learn, where you're going to select by default Minkowski, but p value, if you observe, p is equal to by default 2. By default 2 means it is Euclidean. Is it clear? That is why it is Euclidean. Is that clear? Hmm? So can I
Yes,
get a
one. Yes, it's clear.
got it? Yeah, yeah. So
Yeah.
that is how k nearest neighbor algorithm works. Basically, it requires two things. K k nothing but n neighbors. By default, it is 5, and remaining thing is obviously p is equal to by default Euclidean. P is equal to 2 means Euclidean distance. If you insert p is equal to 1, then it will take the Manhattan distance. So it is up to you. You can try different parameters and you can check which one is really giving the best accuracy, and then like that you can consider. And you can explore remaining things. What is exactly this weights? What is this algorithm? What is this leaf size? And again, metric parameters. By default, it is none. But if you need metric parameters, it is very easy. It is an additional metric parameter like accuracy or something like that. And n jobs. Okay, one means unless here you can get this by minus means we are using all processors and all. So these are all by default anyway. We are not going to change much. Only these two things we alter lot of times. Okay, let us see how we can implement the k nearest neighbors. But before going to k nearest neighbors, uh, anybody here would like to you know uh, share the approach what I'm going to show now? Anybody here would like to try the approach of the data set which I'm going to share you? You can share your points if you're interested. Otherwise, I will only explain. But anyway, we have uh, come across different type of classes where we discussed about the data pre-processing, feature engineering we discussed, selection of algorithms we discussed, and different domains also we discussed. So anybody here interested to add points, whether it is true or not, right or not, let it keep let us keep those points away. And if you're wrong, I will correct you. But in what way you wanted to solve, that is what the thing I am expecting. Is there anyone?
I think just classifying it. I mean, if you are using the KNN approach,
No, not
um,
not at all KNN approach. That algorithm is let it the last. I will show you
okay,
the data set. What
okay.
steps that you're going to perform after seeing that data set is what really I need. Algorithm selection, let it be KNN, SVM, or a logistic or naive base. Also, by the way, we already discussed naive base. Naive base. Yeah, algorithm selection is last thing. But before that, I already showed you, right? The data science life cycle. It is anyway here. So business understanding is important. Data understanding, data preparation, EDA is very important. Here comes the machine learning. Let this step at the last. Let this keep this step at the last. But before these four steps, if you really get to know the basic things out of the data set, then most of the job done. Okay, most of the
I
job
mean,
done.
first, I think first understand the data set and decide what our end goal is,
Mm-hmm.
and then understand like what kind of data set we have, and then try to do exploratory data analysis, and then like if we have some missing values, understand those, fill them with like mean or the
Exactly,
best way possible, and then
exactly.
like basically cleaning the data, preparing it, and then if we have any categorical data we need to encode it, understanding that, and then like with what our end goal is, we can either choose the model, like either we are going to choose classification or regression or clustering, or
Yes.
we are going to reduce the dimensions, like dimensionality reduction, and
Mm.
then I think does that answer what you were
Yeah, correct.
you
Exactly, Maria. Exactly. So now what I will do is I will show you the data set and I will explain you the basic domain. Okay, I will brief you out the domain. Then you have to recommend me. You are anyway told the many ways to do, but the right ways, what exactly comes into your mind, and also what can be the best way. And by the way, the things what I am expecting is the concepts which I already covered. Okay, noted to worry. Let us see. Let us see. This is our data set. Okay, the data set explanation. This is again healthcare. The reason why I took most of the time healthcare and automobiles is there are quite common and large availability of data sets are there. But when it comes to aviation, I still need to cover the time series analysis. That is why I'm not taking these days the aviation needs time series analysis and also sequential problem statements. Probably aviation data sets will come at the machine learning end and deep learning half of the deep learning. At that point of time, only aviation data sets and stock market data set that data sets will come. Till then, we will continue with the mostly either healthcare or automobile or e-commerce sometimes. In NLP, e-commerce mostly will come. Okay. So here you can see the citation means the ones who created this data set and all. Let's keep it this side. Physician given and 1992 the data set is being reviewed and then given. Okay. Here, if we observe, let us keep all such important points later. We can decide. I mean, we can study them later. But now it is what very important. Here you can see these are the attributes. Attributes means also known as, the column names. These are the column names. Look at the column names carefully. Sample code number. Sample code number, it is simply an ID. And it is also a number, a simple number, right? Uniquely identified number. And then clump thickness. Clump thickness is one parameter, which is, it is data set of, heart disease. Okay, heart disease. There are only two classes, benign, I don't know how to pronounce it properly, and malignant. Okay, malignant and benign. Okay, there are only two classes. Benign means one type of heart disease, maybe. Malignant means maybe one more type. I'm also not sure because these two terms mostly we will find out in medical researches and all. I had to figure it out what these terms are. I also saw the same things in cancer detection also. Maybe it is a breast cancer only. Yes, it is breast cancer data set only. Yes, these are cancer types. I guess benign and malignant. Benign is representing by two. If two is there in the class, that means benign. If four is there in the data set, means that is called malignant. Got it? That is what the class they define. And in order to define a person is being affected with benign or malignant, then we need some parameters, right, to validate. Such parameters are: first is clump thickness, uniformity of a cell size, uniformity of a cell shape, marginal adhesion, and single epithelial cell size, bare nuclei, bland chromatin, normal nuclei, and mitosis. These are the medical terms. So, which is being calculated maybe from the blood or from. Okay, let me see. Someone is going to join. Benign means non-cancerous. Yeah, we just. Okay. Thank you, Maria, for adding the points. Benign means non-cancerous. Okay. And malignant may be cancerous, right, Maria?
Yes, so benign is just like
Benign.
some lumps, yeah, and
Okay.
malignant means it is definitely cancerous.
This is
Benign means it's
cancerous.
just lumps, yeah.
Got it. Thank you for adding these points. Yeah. Benign means, as she mentioned, this is not cancerous. And malignant means cancerous. So ultimately, we have to define whether a patient is going to affected with either malign means not cancerous and cancerous. Then how do we solve this means? See here data points, it is very clearly mentioned where it started, where it ended, 1 to 10, 1 to 10 and all. And then it is also having 16, okay, missing values because they were not known. They are denoted by question marks, unavailable, missing, denoted by question mark. And that is what the simple overview of the data set. In reality also you will be given the same way, documentation you will be given to solve. So where you will get to know the description of every column and what exactly it is, what is the typical value, everything will be given to you. So you have to go through the domain, you have to do some research and then know the reality and then see the data points whether it is matching the reality. If it is yes, okay, then fine. If not, means you have to discuss with the domain people and then approach them. So share your thoughts and modify the data if required. All such things also a part of data scientist. Okay, so let us see, this is the data set. Then if we see the data points, okay, the data, if I'm reading this data, I'm not having any values as a columns. Okay, I'm not having any value, a column names or attribute names are not there, simply 0 1 2 3 4 till 10 are there. So first step is to mention the column names. How do we get to know? Already we have given, I mean we were given the data set from them. So there are total 11, you can see. The same names you can just enter. Okay, the same name you can just enter and form a list and then just replace the columns with from 0 to 10 to. This is first step. So by looking at the data set, immediately you have to know, and there are no column names, so I have to replace with the valid column names. Now this is what the data set. Okay. So now the first step, Maria already mentioned, null value. If there is any null value, of course they already mentioned null values are 10, so we have to identify which column are having null values. They had just mentioned the number, but which column exactly it is having also we have to find out. And then do really id important, do really id an important column to define whether a class is malign or benign, huh? So the other one I'm confusing. Yeah, Benin, Benin and Melanin. Is ID is really important one? So to define the class, right? No, isn't it? These
Yeah.
are all the
Yeah.
blood values. Correct, right, Maria? Yeah. ID is not at all going to take important factor here. So simply we can remove that one permanently. After that, if we see this is the data final points, okay. And then if you observe one thing here, the data info function is very important. I mentioned many times why it is means here we have to cross check. Here it is showing as a number, okay. But here what is the exact data type it been occupied? We have to cross check. So integer, yes, integer, integer, integer. But this particular column, if you see bare nuclei, we are having an object. That means if I go and do the runtime restart session, so that I can run from the beginning. Okay. So where's my mouse? Just give me a second. Yeah. Okay. So if I'm running this and then data shape head is done, columns are done, this is also done, and dropping also done, info done. Now before that, just check that how many rows of the values this bare bare nuclei. So if you are interested into healthcare means you can check out. So you can check out that what exactly this is. Okay. First of all, you have to identify the unique values or value underscore counts. I will go for unique. I can identify that there is, yes, there is a question mark is there. They already mentioned. So that is why, non-null count, you can see all are 699. The total rows are also 699. Initially, we printed the shape 699. But there are null values. How do we identify this? Means this is one good way to identify directly from info function. Got it? So later on, okay, later on what we can do is we can replace this with null value. That that is what I explained in the last session. I mean SVM. I have given you the code where you can replace it with null value. So all such values, if you want to identify that values, bare bare nuclei, okay, equal to question mark. If you identify the values which are having those dot log function, I already explained, right? You can use that log function to filter out the data which are having these question marks. See, these many question mark values are there. You can bare nuclei, all are having question marks. Okay. And also let me print the describe function. So and observe whether this ball, what is this column name, bare nuclei. Okay, whether okay, anyway bare nuclei did not come because according to the data points it is object, so object points cannot come in describe. Okay, object only numerical values only will be there in describe, I already mentioned. So that is why we cannot see the object. First of all, let us replace this question mark with some other data point, either zero or null value. After that we will convert the entire column into numerical and then find out. Okay, that is a strategy. Yesterday I explained you how to do, uh, you know, um, how to do replace with null value and then converting. So now I'm going to explain you one more way. This is called toNumeric is the function where you can specify the numerical column, but it is actually because of the symbol, it is actually showing you the object, right? Such columns you can pass it to this particular function. After that, you can mention this errors is equal to cohere. Okay, so that what will be given is, so it will automatically get converted into that, and then will show you the null values also. So they will treat it as null values. Now df.describe, if you go for df.describe now it is, see, you can see here bare nuclei also part of it, because we just directly converted two underscore nuclei. Numeric is such function which will help you to do that directly. Otherwise you can do the simple strategy, which is convert them to the null, and then convert the entire to what we can say the numeric, and then do the rest of the operation. Describe. Okay, bare nuclei, if you observe, the mean is 3.5, where the median is 1 only. So I can easily identify that the, it is not normally distributed.